Hi everyone, we're going to graph our g of x function here. We're also going to test for continuity at x equals 3. And one more thing, we're going to evaluate it at these points here. So, the first thing we do is going to test for continuity. And the definition of continuity means it must meet these three conditions in this order. So we're testing at x equals 3. Therefore, what we want to do is, that is our C. Because this is, the graph is changing at 3. So we're going to try g of 3. And you plug it in, have to plug it in this one because this is only where it equals it. So 3 plus 5 equals 8. So condition 1 is satisfied because it does exist. It equals 8. So the next thing we have to do is test condition 2. That is the limit as x approaches my 3 from the left. That means all numbers less than 3, up to 3, of f of x should equal all the numbers to the right of 3 as the limit gets closer and closer to 3. So all we're going to do is to the left of 3 is all numbers here, and we already did that. It equals 8. So that's 8. Now all numbers bigger than 3, I plug it in here. So this would be 2 times 3 minus 1. That's going to equal 5. These two do not exist. These two do not equal. That means condition 2 is not satisfied because the limits do not exist. The left-hand side and the right-hand side, that means the limit doesn't exist. So does not exist. So that means we're going to have some discontinuity in the graph. So let's graph it. Everything's happening around our 3. So I'm going to plot the 3. We already know at 3 that went to 8, which is about here. And it can equal it. I also know my y-intercept is 5. Because it's linear. 1, 2, 3, 4, 5. And so I know it's a line, so I can just go down and kind of sketch a graph like that. Alright, so that's all numbers to the left and equal to 3. Now at 3, bigger than 3, let's test 3. So 2 times 3 minus 1 was 5. So 1, 2, 3, 4, 5. And that's going to be an open circle. You always have to put the 3 in, even though it doesn't equal it. Because you can, it could be, your point could be 3.0000 ... 1. So you want to get it close to 3 as possible. So let's plug in 4. What's happening at 4? 2 times 4 minus 1 is 7. So let's go, 4 goes to 7, which is about there. We only need 2 points, so there's your graph. Something like that. And there you can see why this graph is not continuous. Because if you go along from left to right, you're drawing, but you have to pick your pen up to go back down to here and then draw this piece. Because the function is supposed to be taken as a whole. So this is called a jump discontinuity. And that's why condition 2 failed. Discontinuity. Alright. Now, we have to evaluate these. So, at g is 7, I'm going to plug it in this one. So, let's just do this mentally. That's 2 times 7 minus 1. That's 13. For 0, 0 is going to go on this one because 0 is less than 3. So, that equals 5. And then for negative 1, that also goes in the upper portion. Negative 1 plus 5 is 4. And then for 3, we already did that one, so 3 plus 5 is 8. And that's it. Thank you. Have a nice day. Bye-bye.